Let's do a problem that involves solving a linear equation where the equation isn't just dumped in our lap, but we have to work for it a little bit. This comes from Chapter 2 in your integrated textbook. In fact, this example and the two other examples in this topic are pulled from the review section for Chapter 2. And so if you're in ALEKS and you open up the integrated textbook, in the upper right-hand corner, you should see a little drop-down that allows you to select sections from Chapter 2. And one of those sections is called Chapter 2 Ending, and that will give you a comprehensive review of each of the sections in Chapter 2, followed by review exercises, and then sort of a comprehensive test, as you normally see at the end of a chapter in a textbook. And that's where I'm finding these. So this kind of stuff is coming right out of your integrated text, so it's easy for you to dive in there and go find similar problems if you would like to see more examples. So this story tells us that there are two integers. They're both odd. They're right next to each other. There are even numbers in between, but the odd numbers are close. Hopefully you get the idea, like 5 and 7 or 17 and 19. And when we take these two odd integers and add them up, we're going to get 156. And our job is to find out what these integers are. Well, we have to introduce a variable because something here is unknown, and so it requires an unknown, which is a variable. And so I'm going to identify this variable. I'm going to say let n for number, because I'm clever that way. I'm going to say let n be the first odd integer. I'm a lefty, so you'll have to wait for my hand to get out of the way. All right, so we've named one of our two unknown integers. We don't need a totally separate name for the second one. We can build the second one based on the first one because we're told that these are consecutive odd integers. And there's a pattern. For number 5, the next consecutive odd integer is 7. For the number 27, the next consecutive odd integer is 29. For any odd integer, the next odd integer is 2 more than the one you just had. And so if n is the first odd integer, then n plus 2 is the next one. And we're told that the sum of these two things must be 156. And so the first integer n plus the second integer, which is n plus 2, the second of the consecutive odd integers, and that sum has to be 156. And now it's our job to solve that. Now in this problem, like so many others like it, the hard part is digging into the words and coming back with the equation. Once you have the equation, the actual solution of it shouldn't be too bad. So this left-hand side, there's an n, there's a plus n, so that simplifies to 2n. The plus 2 is still there, and that equals 156. I would like to subtract 2 from both sides. I'm hoping we can imagine that step happening, and so that I don't have to write down a new expression with minus 2 in place on the left and the right. Let's just imagine having subtracted 2 from both sides. That will leave us with 2n equals 154, and then we will be dividing by 2 on both sides. I don't know if you can hear that, but that's Zoe the algebra dog in the background. She's very excited that we're doing this. I'm dividing both sides by 2, which will leave me, I'll write that down. How about just to be sure, right? Dividing both sides by 2, that leaves me with n on the left, and then 154 divided by 2 is 77. Now, what we don't do here is put a box around that number and say ta-da, because the question is, what are those integers? So the answer is not just one of them 77. We're told to identify both integers. And so we conclude with a statement that directly answers the question. So the two, mailman must be here. The two integers are 77 and, because we want to provide both of them, but if 77 is the first one, the next odd integer up is 79, and if you test that, if you add 77 plus 79, you will indeed get 156.